minimize this, take a picture. Now I have a couple of ways of doing this. It doesn't bother me writing on top of other words. I hope it doesn't bother you.
No.
Because I can open a blank sheet and write on the blank sheet if you feel it matters. Maybe if I use a different color other than black, it won't matter as much. All right. First of all, let's talk about a couple of things. That's standard form. Okay?
Okay.
That's not. That's y totally solved for. Okay?
Okay.
So when you have two equations like this, here's the rule you want to use. If they are both in standard form, you still there?
Yeah.
Okay, I heard a beep. Wasn't sure what that meant. Afraid I might have lost audio with you. If both equations are in standard form, for example, that set, notice why they're in standard form?
Because it's
It fits this right here.
Yeah.
AX plus BY equals C. When they both are in standard form, we're going to use elimination always.
Okay.
When one of them is defined in terms of either variable, doesn't necessarily have to be y, it could be x. But if one of them is defined like that is, and the other one is in standard form like that is, then you want to use substitution. That's it.
Okay.
It's as simple as that.
Okay.
Okay? Now let me erase everything and we'll see if you learned it. So how are we going to do number one? By substitution or elimination?
Substitution.
Okay. And what you basically do is you go into the equation that's in standard form, and wherever you see y, you substitute that. So tell me what to write.
Okay.
4x, what?
Minus or plus.
Let's write it all. We'll simplify afterwards. I
Okay.
don't want you doing two steps at once. That's the surest way to make mistakes in mathematics for anybody. So let's do it, especially when you got lots of plus and minus signs. The worst thing you can do is try to do it all in your head in one step. So, what am I going to subtract?
Negative 3x plus 7.
That need to be in parentheses?
Yeah.
Absolutely. The parentheses are everything there. Equals 0. Okay? So, now we just have to simplify that. And to simplify stuff, a good starting place is to remove denominators and remove parentheses. Well, there's no denominators, but we can certainly remove the parentheses. So what do I get when I remove the parentheses?
4x plus the 3x plus 7.
Hold on. That negative sign, the reason I put the parentheses in there was because that negative sign has to apply to everything inside the parentheses. Always.
Okay, so negative 7 equals 0.
Simplify further.
So 7x minus 7 equals 0.
Further.
7x equals 7.
And finally,
x equals 1.
actually not finally, because all we did was solve for x. How do I solve for y? Because we always need to solve for both variables here.
Right.
How am I going to solve for y?
Plug in x.
For which equation?
The first one.
Probably that's the easiest one because that's got y all by itself on the left. So what's y equal to? Minus 3 times what?
7 or 1.
So what's y equal to?
Negative 3 plus 7.
What is that?
4.
There you go. There's your two solutions. And that's always the way you're going to do it when you use substitution. Okay?
Okay.
Now, let's look at the second one, where in the second one, we've got two equations that are both in standard format. Well, it turns out there's an easier way to solve these. And that's to put one below the other. Okay? Label that equation 1, label that equation 2. Now, our goal is going to be, as the name suggests, elimination. We're going to try to eliminate a variable by adding or subtracting these equations. Well, at the present, I don't do that. If I add or subtract, remember you can always add equations. You add the left side and you add the right side. You can also always subtract equations. Okay? So the goal here is to get an equation in the form where if I add or subtract, one of the variables goes away. Well, what can I do to equation 2?
So
In other words, I'm going to try to make equation 2 such that I'll be able to add it or subtract it, either one you can do, and one of the variables goes away.
right. Okay.
Well, what if I multiply equation 2 by 2? Both sides.
Okay.
You can do anything to one side of an equation as long as you do it to the other side. So I multiplied it by 2. Now that's equation 2.
Okay.
Now, how do I get a variable to disappear?
You do elimination. So
Well, but what do I do? Do I add the two equations or do I subtract them? Subtract. In other words, if I subtract positive 2y from positive 2y, that's 0y. And I'll end up with nothing but x. So let's try that. That's not the easiest way, but I'll go back and we'll look at this again and I'll give you a slightly easier way to do it. But
okay.
It's important to understand that you can either add or subtract these equations. So what's 7x minus a minus 6x? I've already decided I got to subtract them because I want 0y.
Right. So that's 11x.
13x.
Or 13.
Plus 0y equals, what's the number going to be?
Negative.
Hold on, it's 5 minus, here, it's 5 minus a minus 34. That's what we're doing.
Okay, so then it's 39.
Okay. Now, x is 3. In other words, once I eliminate one of the variables, and it doesn't really matter whether it's x or y, you just got to eliminate one of the variables, then you're left with one equation and one unknown, which you can solve. In other words, I was able to solve for x. And now, how do we solve for y?
Plug in x to the first equation.
Okay? So tell me what to write.
So 7, and then in parentheses, 3 plus 2y equals 5.
Okay, simplify and solve for y.
Okay, so 21 plus 2y equals 5.
Okay.
And then subtract 21 from 5, so
Okay.
16. And then divide by 2.
All right, so there's the second solution. Okay. Now, just notice for a moment that it would actually, my math would have been a little simpler if I'd have plugged in the x value into the second equation.
Okay.
Because that's almost solved for y already. In other words, all I got to do is move that 3x to the other side, and I end up with y equals 3x minus 17. Now if I plug 3 in, I get y equals 39 minus 17. That's very interesting. Did I make a mistake in my math here? I must have. When we plugged in 3 for x, we had 21 plus 2y equals 5. 2y equals 5 minus 21, which is minus 16, which means y equals minus 8. And it should, the same two solutions have to work in that second equation, do they? Minus 3 times 3 minus 8, is that equal to minus 17? Yes, it is. Minus 9 minus 8 equals minus 17. So both of those solutions are the right solution.
Okay.
Now, do you understand what I'm saying? Would you prefer I write on a blank sheet of paper, or is this okay with you, that I write on the top of writing?
That's fine.
You can understand this?
Yeah.
Because I have another thing I can open up and write on, but it's hard to go back and forth between your problems and my writing. So I've discovered that this is, I believe, the best way to do it. Especially
Yeah.
a different color. If I use pink, you should be able to distinguish the pink from black. Number 3. What method are we going to use? Going to use substitution or elimination?
Elimination or substitution.
Correct. That's in standard format, but that's not. That's in slope-intercept format, where y is fully defined. We're going to use substitution. So tell me the next thing I should write.
Okay, so y equals negative.
We're going to substitute. Let's take that and substitute it for that y. Because if we do it the other way around, you don't know what x is, right? You do not know what x is. You could solve for x, but at the moment, you don't know what it is. So doing it the reverse way is not helpful.
Okay.
If I take this y and substitute it into the standard format, what do I get? I get 4x, what? Keep going.
Minus 3, and then in parentheses, negative 2 over 3, x plus 5.
Now simplify that. Oh, excuse me. And that's equal to minus 6.
Yes.
Notice that now I have one equation and only one variable. You can always solve one equation and one variable no matter how complicated it looks. It's simple to solve that. Once we solve
Okay.
for x, then we plug it in to that one and solve for y. So let's distribute this, simplify it. What do we get?
So 4x,
Move the parentheses. What is that number times that number?
I don't know.
Plus 2. Okay, here, let's look at it over here on the left. Multiplying minus 3 times minus 2 over 3. Okay?
Yeah.
First things, the 3's cancel. Next things, the 2 minus signs become a plus sign. The only thing I have left is plus 2.
Okay.
Okay?
Okay.
So, what I have here is plus 2x. So I still have this x. That has to be included. And then finally, what's the number? In other words, what's that times that?
Negative 15.
Still all equal to negative 6. Tell me the next line.
So that's 6x minus 15 equals negative 6.
Okay, and then once you move the minus 15 over, what do you got?
2x equals
Still 6x.
6x. Sorry, 6x equals negative or positive 9.
So x is equal to
9 over 6.
simplify
3, I think.
3 over 2.
3 over 2.
In other words, the way I simplify 9 over 6 is to divide that by 3 and divide that by 3. I can always divide or multiply top and bottom by the same number on any fraction without changing its value. So that's x. Now we plug that in to that equation, and that will allow us to solve for y. And it actually becomes quite simple. It becomes minus 2/3 times 3/2 plus 5. Well, what's minus 2/3 times 3/2?
It is negative 6 over 6, so negative 1.
Yeah. I'd rather see you not do it the way you just did it. It's not negative 6 over 6. What I'm going to do here to do this math is, first of all, cancel those 2's, cancel the 3's. The only number I have left is 1 on top and 1 on bottom. So you get there without dealing with larger numbers. The problem when people multiply these numerators and then the denominators is you end up with much larger numbers than you need. Let's say I have 5/7 times 35/10. Okay?
Okay.
If I want to do this math, I can certainly multiply 5 times 35, but I probably got to use a calculator. It's 165. And then I got to multiply 7 times 10. And then I got to somehow reduce that. Well, that's a bad way to do it. Let's start by dividing top and bottom by 5. So that becomes a 1, that becomes a 2. Now let's divide top and bottom by 7. That becomes a 5. That becomes a 1. And now what do I have? 5/2. That's what that is 5/2. far simpler if you simplify first.
Okay.
Rather than just straight multiplication of the numerators and the denominators. Always, always simplify. Don't depend on your calculator. I mean, I know you can put this in your calculator and it'll tell you 165 sevenths, and if you hit it enter again, it'll probably reduce it down to 5 halves. But this is such an intrinsic part in math that you really need to be good at this. And part of being good is simplifying before you multiply one fraction by another.
Okay.
So the answer to y was minus 1 plus 5. Minus 1 plus 5, or 4. That was number 3. Okay, hold on. Let's look at number 4. Which method am I going to use here?
So, elimination.
Yeah. Now, there's a problem. If I write minus 5x minus 20y minus 15. And the problem is that I basically have to find a common denominator between either 4 and 5 or 16 and 20. Okay?
Okay.
That's not really that easy to do. I mean, I guess I could do 20, and for illustration purposes, maybe that's what I'll do. There is a shortcut here that I want to point out, but there's not always going to be a shortcut. Okay? So that is what we're going to call equation 1 and equation 2. Now,
Okay.
use elimination. But I can't multiply just one equation by a whole number and come up with minus 5 or minus 20. Can't do it. But what if I multiply the top equation by 5 and the bottom equation by 4? Okay? So the top equation, both sides have to multiply by 5. Bottom equation, both sides have to multiply by 4. That's going to give me 20x and minus 20x. Then I can add the two equations and x will be eliminated. So,
Okay.
what's my new equation 1? Remember,
So,
I'm multiplying by 5.
So 20x plus 80y equals 60.
And what's the second equation going to make? Multiply
Negative 20. Minus 80y equals negative 75.
4 times 15 is negative 60.
Oh.
Now,
Yeah.
notice that if I add these two equations, what do I get? I get 0 equals 0. Tells me nothing. Actually, it tells me a lot. It tells me that both equations are the same. Well, you can't make two identical equations and solve for anything. In other words, if I tell you over here on the right, x plus y equals 10, and then I give you a second equation, 2x plus 2y equals 20, I'm not going to be able to solve for x or y. The second equation is the same as the first. Okay? So when you go through the solution and you get one number equals another, and usually it's 0 equals 0, Well, what that means is both of these equations were the same to begin with. And if we go back up to these equations, notice that I could simplify both of them rather easily, right? Instead of dealing with all those numbers like 80 and 60, what if I start by dividing this equation by 4? Well, what do I have? X plus 4y equals 3, all right?
Okay.
Now what if I take the other equation and divide by minus 5? I have x plus 4y equals 3. We're looking at two identical equations, which means that having two equations isn't going to help us solve this at all. If I just have one equation and two variables, I have an infinite number of solutions. Infinite. Well, if
Okay.
I have two equations that are exactly the same and two variables, I still have an infinite number of solutions. And if you do this simplification first, you see it immediately. You see that you're looking at two equations that are the same. But if you don't do it first and you try to solve them by the methods that I've suggested with elimination, you get a very strange answer. Both variables get eliminated.
Right.
Well, let's take the third situation that you might have to understand. And that's where you have one equation, x plus y equals 10. And you have another equation, x plus y equals 9. Might not be apparent, but those two equations are not compatible with one another. If equation 1 is true, then equation 2 cannot be true. Either x plus y equals 10 or it equals 9. It cannot equal both at the same time. And if we try to solve it, let's say I subtract equation 2 from 1, I get 0 equals 1. Well, whenever you're solving a system of equations and you get one number equals a different number, that means no solution. So
Okay.
there's actually three possibilities. There's a solution for each variable. We got that with problems 1, 2, and 3. Second, there's an infinite number of solutions when you really only have one equation, and we got that with number 4. And then the third possibility is no solution. And we got that when I had one number equaling a different number. If I have one number equals the same number, it's an infinite number of solutions. If I have one number equaling a different number, you know that that's impossible. That goes with the no solution.
Okay.
Okay? I want to do something. Just want to suggest a website that might be worth you spending a little bit of time on. I'm going to copy and paste this in to the chat window. You see it?
Yeah.
Click on that link.
Okay.
Should open the same browser page that I have, pretty much. Maybe with different numbers, okay? Save that link so you can get back to this page.
Okay.
Okay? Now, minimize your GoToMeeting panel. We don't need it fully up anymore. I want you to show me how good you are at this, and do not use a calculator. Do it as fast as you can do it.
Okay, hold on.
No calculator. I want you to do these in your head. I don't want you to, I'm sorry, let me be clear. Demetrius, I don't want you to do it on your screen. I want you to look at my screen and answer the questions that come up on my screen. Just verbally tell me the answer. In other words, 5 times 11 is 55. And I'll input it, and then I'll get another problem, and I want you to do that. Okay? The only reason I had you click on it on your end was so you'd be able to get back to it. Because this is something you can practice on your own. And trust me, there's nothing you could do for your math skills better than spend 5 minutes a day on this site. I noticed that there's some slowness, and you're not always 100% accurate when you do these single digit by single digits. You simply cannot advance in math without being perfect at these. So that's why I want you to not use a calculator. I want to see how much effort or how much work you need to do to get perfect at these. So what's 3 times minus 4?
Negative 12.
Next.
99. Or negative 99.
This is subtraction, not multiplication.
Oh.
In other words, it randomly mixes it up. Okay? So sometimes it's going to give you an addition problem, sometimes a subtraction, sometimes a multiplication, sometimes a division.
So 2. By the 56.
If you cannot do these accurately within 5 seconds of seeing it, you need to spend some time on this page. 8 times 9 is 72. Let me give you a little secret about the 9s. Notice that every time you multiply 9 by a number, you get a number that adds up to 9. 1 and 8 adds to 9. 9 times 3, 27. 2 and 7 add to 9. 9 times 4, 36 adds to 9. In fact, notice the pattern. This digit is always 1 less than whatever you're multiplying 9 by. So if I'm doing 9 times 8, I know the first digit has to be a 7, and the next digit has to be a 2 because they have to add to 9. Now, minus 9 times minus 8, 2 minuses is a plus, so it's still 72. And that holds for all 9s. If I do 9 times 12, I get 108. What do those 3 digits add to? 9. And in fact, you can take any large number like that. Is that divisible by 9?
Yeah.
Yeah, because the digits add to 9. And only numbers that add up to 9, where each digit, when you add it together, they add to 9, are divisible by 9. If that added to 8, if it was 1115, I would know that is not divisible by 9. So this is a pretty useful trick. Okay. Before we leave this page, I'm not quite ready to leave this page. I want to impress upon you the importance of practicing on this page. What I have found is that most problems that my algebra students have is not with algebra. It's with this. You cannot depend on a calculator to do this. You just can't. It slows you down too much, and everybody's going to expect you to be able to do this without a calculator. If you have to depend on a calculator, you are way behind. Okay? Now, not to say you're alone. Half of my students have to use a calculator to do this problem. They do. And one of the reasons, part of the disadvantage you have at being a 21st century person is that you've always lived with calculators. And the downside of that is that you know you can be 100% perfect, but you got to use the calculator to do so. And anytime you're not 100% certain, you use the calculator, and guess what happens after a while? You can't do them in your head anymore. I had a student a few years ago that to multiply by 10, she had to reach for her calculator. That's how dependent she was on her calculator. And you can go so far by doing that. You might even get through Algebra 2. But once you get into precalculus and calculus and higher maths, it just does not work. You've got to be able to do these on your own. What's this one? Let's go through these fast. Fast as you can.
It's 6. It's -7. -4.
See, you get pretty good once you practice.
0. 1. 3.
Aha, this one tricks everybody.
-3.
Oh, I'm sorry. I didn't mean to close that out. Hold on a second. Just one moment. This is the key one. You got to be able to do this one. This is the one that trips everybody up. That was -10 -7, correct?
Yeah.
Okay. Here's why everybody has a problem with it. First of all, there's 2 dashes there, and they both mean something different. The first one means -10. The second one means subtraction.
Okay.
Okay? What I tell every student I have is treat all subtraction problems, if they are confusing at all, as addition problems. And what you do is you change the subtraction sign to an addition, and then you change the sign on what was being subtracted. In other words, this problem is the same as this problem. Only nobody misses this. What's -10 plus -7?
-17.
Yeah, that's a piece of cake. Nobody gets that wrong. But you give people that one and half the field misses it. But you won't if you change all subtraction problems to addition problems. Now, you know, in other words, if we did this one, well, there's the subtraction sign, right?
Yeah.
So let's change it to an addition sign. And the moment I do that, I got to change the sign of what was being subtracted. So now, piece of cake.
Okay.
And it applies if there's parentheses. If I have something like this. Okay, over here on the left. Okay,
yeah.
Here's the subtraction sign. I'm going to change it to a plus, and then I've got to change the sign on everything inside the parentheses. Now I can remove the parentheses. Again, piece of cake. -5 when you combine the numbers plus 3x. So if you treat all subtraction problems like that, you won't make as many mistakes. Now, clearly, some subtraction problems, you don't need to do that. If I tell you 10 -7, you don't need to treat that as an addition problem. You know that's 3. And if I tell you 7 -10, you know that's -3. But the moment I have a negative number minus a positive number, that throws people. Turn it into an addition problem. Add the parentheses like that. All right. I don't want to belabor that point, but I would suggest you spend some time on that, and I guarantee you it will improve your math immensely. I would bet anything that you're making some arithmetic mistakes when you take tests now. Is that you multiply two numbers or add and subtract a number and you make a mistake. And you don't want to make those kind of mistakes. You should be 100% perfect with those kind of problems. If you don't understand the algebra, that's one thing. But if you get really, really good at this, trust me, the algebra comes really easy.
Okay.
It no longer becomes difficult. I don't know how to stress that any more than saying that. But that's what I truly believe. Hold on a second. Now, so what we discovered was that equation was the same as that equation. It's just kind of in disguise. It's not readily apparent.
Okay.
Let's go ahead and do 5. I don't want to end our session without doing at least some of these word problems, because word problems really give people problems. What am I going to use for number 5? Substitution or elimination? Notice, as long as you have one equation defined in terms of one variable, you always want to use substitution. Always. You don't have that here. You don't have it here. Those are both in standard format. I do not have x defined or y defined in either one of those. But over here, I have both y defined and x defined. So I can do this one of two ways. I could substitute x in for that, x, and solve for y, or I could do it vice versa. Either way.
Okay.
Let's do it the simple way. So I'm going to substitute y equals 4/3. What's x?
3/4 y minus 3.
And always use parentheses. If you're ever in doubt about parentheses, use them. Never wrong to use them, and sometimes incorrect to not use them. So what's y equals?
1y, so y. Negative or minus.
3's cancel, and you get minus 4.
Yeah.
Because you have 4/3 times minus 3. Those cancel. Replace it with a 1. So you have y. Of course. Okay, yeah. I don't know if I confused you or not. I didn't mean to. But that's what you get. Okay?
Okay.
Now subtract y from both sides. You get 0 equals minus 4. What's our solution?
No solution.
Exactly. In other words, there are no values of x and y that make both of those true at the same time. Impossible. And we found it out by trying to solve it, and we get one number equals another number. All right. Do at least one of these word problems. Everybody I know hates word problems. They shouldn't.
Yeah.
Word problems are the easiest ones in the world. You just have to know where to begin. And where you begin is by defining your variables. How do you do that? You look at the last sentence. I don't mean the little note they gave you after the last sentence. I mean that right there. That tells you exactly how to define your variable. What should x be?
The cookies.
Number of cookies sold.
Yeah.
Not just cookies. because cookies in this case have a price, and then there's how many were sold. So they're not the same thing. So you don't want to just say cookie, because that might be confusing. They might think that we're talking the price of a cookie. What should Y be?
The number of eclairs sold.
Okay, perfect. Now we're ready to go. If we sold $680 worth, and cookies sell for $275 and eclairs sell for $425, tell me an equation that makes sense. How much did I make in cookies?
$680. Oh wait.
Just cookies. Cookies sell for $275 each, and I sold X of them. That's what I made from my cookie sales. Right?
Okay.
If I sold 10 cookies, I made $27.50. But I also sold some eclairs. And each eclair goes for $425. So what did I make in eclair sales? $425 times the number of eclairs I sold. And all total, I made $680. Well, at the moment, I can't tell how many cookies and how many eclairs I sold, because I have two variables in one equation. You cannot solve that. There are an infinite number of solutions always, whenever you have two variables in one equation. So I need another equation. All of these problems up here, in order to solve them, we had to have a second independent equation. It can't just be a multiple of this equation.
Okay.
What's my second equation?
How
many total cookies? How many total baked goods did I sell?
172.
So what equation does that translate
to?
The number of cookies plus the number of eclairs is equal to 172. What equation is that?
What is it called?
Here's the number of cookies I sold. What variable is that?
X. So y-intercept, or?
No, X plus Y. That's the number of cookies plus the number of eclairs. And they're telling me I sold 172 baked goods. So there's my second equation. Okay?
Okay.
Now, that is not the same as the first equation. That is a separate second equation. So if I can solve this system of equations, then I will know precisely how many cookies I sold and how many eclairs I sold. This is a very practical problem, really. I mean, when you run one of these bake sales, you end up with a certain amount of money in your hand, and you might end up knowing how many total goods you sold, but you might not know exactly how many cookies you sold, and you might not know exactly how many eclairs. Well, this will solve it for you. Now, am I going to solve this using substitution or elimination?
Elimination.
Yeah, because they're both in standard format. Even though it's not going to be easy, but I'll show you how we do it. By it's not going to be easy, I mean, normally you don't want to introduce fractions, okay? But in a case like this, I really can't figure out a common denominator. The only thing I can even think of to do is to multiply the bottom by either 2.75 or 4.25. That'll get rid of one of my variables, okay? And just for the heck of it, let's multiply it by a negative, In other words, the left side I'm going to multiply by negative 2.75. Means I got to multiply the right side by negative 2.75. The only reason I do that is because now my new equation 2, I'm going to be able to add, not have to subtract, which is always easier for people to add, not subtract. So you kind of, when you decide to multiply, do you have a calculator in front of you? Now these, I have no problem with you using a calculator. I do not expect you to do this manually. The only thing that you should always be able to do without a calculator is single digit. Okay?
Okay.
Even 5 times 11 was a stretch, but that's pretty easy. Times 11. There's nothing that gets much easier than that, except maybe times 10. So what's 2.75 times 172?
Uh, 473.
Remember, I was multiplying by a minus 2.75.
Okay. So negative.
So there's our new equation 2. Notice how I got it?
Yeah.
Every term of it. Now, so all I got to do is add old equation 1 to new equation 2. The most important thing is the x's go away. Well, the y's aren't that hard. It's 1.5y equals, if I add those two numbers, I get positive 207. Now it's easy. Y is whatever positive 207 divided by 1.5 is. Again, you can use a calculator on that.
So 138.
And what was Y? Y was the number of eclairs. So I sold 138 eclairs. How many cookies did I sell?
So 172 minus 138. So 34.
Okay. Now let's check. Make sure that that works. What is 275 times 34? $2.75. Sorry.
Yeah.
2.75 times 34.
Times 34. 93.5.
That's how much I earned on the cookies. What is 138 times 4.25?
586.5.
Notice those two numbers add to 680.
Okay. Yeah. Yeah.
So we've solved it. We've checked our solution to make sure that it works. In other words, had they not added to 680, we would have been wrong. We've made a mistake somewhere. And we finally have checked, and that's what that says. Write your equations and solve, then check your answer by graphing. Now, we didn't do that. And we don't have really, well, let me just tell you what they mean by that. I had two equations, okay? They're both linear. Let's say one equation graphed like that, and the other equation graphed like that. Right there is your solution. Whatever x and y value that is your solution. In our case, x was what? It was 34? I don't remember. I think it was 34. The other one was 138. So if we were to graph each of our equations and figure out where they intersect, That's always the solution when you're trying to solve two equations and two unknowns, is graph them, and wherever they intersect, that's the solution. It's just a harder way to do it, to my way of thinking, because a lot of times you have a hard time reading exactly where the intersection takes place. You got to put your what kind of calculator do you have, Demetrius? TI-84 or an Inspire?
So I still need to buy a graphic calculator.
Make sure you buy the Inspire.
Okay.
Okay? I believe it's cheaper, or they're not much difference in price. The Inspire is the newer state-of-the-art one, and I have high schools that force all freshmen and above to have Inspires. They won't even let you use the TI-84. Some schools still let you use the TI-84. But if you have to go out and buy a calculator from scratch anyway, get the Inspire. And there's significantly different learning curves. You don't want to have to learn both. If you haven't spent the time learning how to use a TI-84, you don't want to have to learn that and then turn around and learn how to use an Inspire. So might as well start with the Inspire, especially when they're about the same price. I don't even know if you can buy a TI-84 anymore. If you go to Best Buy or Target or anywhere, what you're going to find is the TI Inspire.
Okay,
and that's the one. All right. There was one problem with that solution. I don't know if you noticed it or not. No, there wasn't a problem. No, I'm sorry. Had we come out with x of 34.5, that would have been suspicious. How do you sell a half a cookie?
Yeah.
So we knew that x and y needed to be whole integers, whole numbers.
Right.
The fact that we made some amount plus 50 cents on cookies, that's okay. If they sell for $2.75 each, you could make $65.50 worth. So that was not a problem. But you want to make sure that these are whole numbers. If they're not, that probably means it's a red flag that you've done something wrong.
Yeah.
All right. And 7 and 8, you're going to basically do the same way. And always on word problems, figuring out the variables is as simple as going to the last sentence. What are the variables in that problem? I always start there. I don't even read the problem. I go down to when I say the last sentence, you usually don't have the sentence that follows that. Okay? In other words, usually these problems end with the sentence that starts, how many vans and cars should they drive? So what are my variables? X is what?
The number of vans.
Okay, you could do it either way. You could make it, as long as you get one variable, it doesn't matter if it's called X or Y, but one should be 1, and the other variable should be the number of cars.
Right.
That's where you begin. Once you do this step, now you go back to the beginning of the problem and you read it, and that will tell you how to write your two equations.
Okay.
Okay? And all word problems are like that, and they're all basically pretty easy because once you define your variables, the rest of it almost solves itself. All right, Demetrius, I will let you go, and I will talk to you on Thursday. Yeah, Thursday.
Yeah, Thursday.
Okay.
All right. Thank you.